Hi guys, this is day 1 of our 30-day A2 economics revision challenge, and the first video is on utility theory. According to the utility theory, when we buy a good or service, we get some satisfaction, and that is the key reason why we end up buying a good. We pay a price to get some satisfaction, which is called utility. Now, there are two concepts in utility that we want to talk about. One is what we call the total utility, and the other one is what we call the marginal utility. So what's the difference between total utility and marginal utility? Well, total utility is simply the total satisfaction that we get from buying an amount of a good or service. So total satisfaction from a given amount of a good or service. A good example of this could be, let's say I consume 5 cups of tea in a day. So the total satisfaction that I get from the 5 cups of tea that I consume in a day is what we call total utility from the 5 cups of tea. The marginal utility, on the other hand, is the extra satisfaction that I get when I consume a good or service. So this is the extra satisfaction from one additional unit, right? So let's look at an example and see how total satisfaction and marginal satisfaction will look like. So on one graph, I'm going to have total utility, and I have the quantity of good that I buy. And on the other graph, I'm going to show you my marginal utility and the quantity that I buy of a good or service. So let's say this is the total utility for tea that I consume, and the graph will look like something like this. So why is this shape like this? We'll talk about this in a little while, but let's first look at some different values that I can put for this graph. So let's say when I consume the first cup, my total satisfaction is, let's say, 15, and the second cup, my total satisfaction is going to, so the first cup is 15. When I consume 2 cups, my total satisfaction goes to, let's say, 25. For the third cup, my total satisfaction goes to, for example, 30. I'm just making up these numbers, but I'm going to talk about the logic behind this in 1 minute. For the fourth cup, let's say the total satisfaction goes to, like 33. And for the last cup that I consume during my day, my total satisfaction rises, but very little, to, let's say, 35. So as I consume each unit of the good, you can see my total satisfaction is going up. But what is important to see is this, that the rate at which it's going up is actually decreasing. Like for the first cup, I get 15 extra. The second cup, my total went to 25, but the difference between 25 and 15 is basically 10. So the extra satisfaction that I get from consuming the second cup is only 10, but the extra satisfaction that I got from the first cup is more, which is 15. And this number becomes, for example, 30 minus 25 is like 5, which means as I consume more and more and more of the tea, my total satisfaction is going up, or total utility is going up, but it is going up at a decreasing rate. And that rate is what we call the marginal utility. Now, when I say rate, I mean to say it's a slope. Slope is always a rate, as we've learned in maths. And this formula for slope is change in y over change in x, which would mean the formula for mu would be change in du over change in q. And that tells us what we call the extra satisfaction from one additional unit. So for the extra satisfaction from one additional unit, for example, for the first cup of tea is like 15. So like if I put the first cup of tea 1, and then 2, and then 3, and then 4, and then 5. For the first, I get, for example, I'm just plotting it, 15. For the second, I get, for example, 10. For the third, for example, I get 5. For the fourth, because third I get 5. Why? Because 3 minus 2 is the third unit. So for the third unit I get 30 minus 25, which is 5. For the fourth unit I get myself 3. For the fourth one I get sort of 3. And for the fifth one I get 2. So if I kind of join these points together, I get myself what we call the marginal utility curve. Now this marginal utility curve is basically downward sloping, and it means that as we consume more and more of a good, each extra unit will give us lower satisfaction than the earlier one. So in other words, what we say that every single cup that I consume, my each successive cup will have lower satisfaction than the one that I consumed previously, and that is what we call the law of diminishing marginal utility, which says this, that as I consume more and more of a good, my TU rises but slowly, which means the MU falls. And this is an important principle to remember, because this principle holds true for many goods, we say, and that becomes like a law, because if it holds true for many goods, it becomes a law. The next thing we want to know is, what's the usefulness of the utility theory? I mean, why do we care about knowing our utility or satisfaction? And the reason is this, that we say there is a goal a consumer has. So a consumer has a particular goal, and that goal is to maximize total utility or total satisfaction, total utility from a given level of income. So if I have a given level of income or a given budget, my goal will be to maximize my total satisfaction from that. The way I spend my money should be done in a manner that I maximize my total satisfaction from that money that is given to me. And we say this, that the way a consumer maximizes his total utility or total satisfaction is through what we call the equi-marginal principle. The equi-marginal principle. This equi-marginal principle simply says this, that the MU that you get from, let's say, good X over price of good X must equal MU of good Y over price of good Y. In fact, this principle, if it holds true, we are making sure that each and every dollar that we end up spending is done in a manner that we are maximizing our total utility. Now, what do we mean by MU X over price of X? Well, it means that marginal utility per dollar spent must be same for all goods. Because if it's same for all goods, then automatically we are maximizing our total utility. Now, why is that the case? I'm going to show you that through an example. So let's say we have two goods, good X and good Y, and in good X you can see this, that the MU that I get from good X is 40, while MU of good Y is 80. Clearly, if you don't show me the prices and you just ask me from the MU perspective, I'll say I prefer good Y over good X, right? Because the good Y has a higher MU as compared to good X. But that's not all that we need to look at. We need to look at, okay, what are the prices? And let's say good X is for $4 and good Y is for $10. So if X is for $4, this means that the marginal utility per dollar spent will be 40 over 4 or 10. While for good Y, marginal utility per dollar spent would be 80 over 10, which is $8. So 8. So this means that MUX over price of X is greater than MUY over price of Y, because MUX is over price of X is 10 versus MUY over price of Y is 8. So I'm going to write this: MUX over price of X is more than MUY over price of Y. Now, as a consumer, if marginal utility per dollar spent is now greater than of one good as compared to another good, what should I do? I should then try to make this ratio equal. Why would I want to make this equal? Because I know this, that the equi-marginal principle says that as long as your marginal utility per dollar spent is the same, you don't need to substitute. But in this case, you need to substitute because good X gives you more marginal utility per dollar spent than good Y. So what should we do? We should buy more of X and we should buy less of Y. But when we buy more of X, what happens is this, that the MU of X starts to fall, while MU of Y, because we are buying less of Y, will start to rise. And this is because of the law of diminishing marginal utility, which says this: as quantity goes up, your MU falls. So the left hand side will start to fall because you're buying more of it, but the right hand side will start to rise because you're buying less of it. But as long as this ratio stays or this inequality stays as is, which is that you get more per dollar spent for good X than Y, you will keep on substituting. You will keep on buying more of X and less of Y. And this substitution of more of X and less of Y will ultimately lead to a scenario where MUX over price of X will become equal to MUY over price of Y. And in that scenario, when MUX over price of X equals to MUY over price of Y, we say the equi-marginal principle is met. This is where the goal of the consumer, which was to maximize his total utility per dollar spent, is taken place, and therefore you no longer substitute. So when the ratio was unequal, we substitute more for X and less for Y, and that led us to this situation where they became equal. And that combination will be the one that maximizes our total utility from a given budget. So this is how we use equi-marginal principle to maximize our total utility. Let's now use this concept to derive an individual consumer demand curve. So we can use this knowledge to actually derive an individual consumer's demand curve. And let's start off with the assumption that MUX over price of X is right now equal to MUY over price of Y. So if MUX over price of X is equal to MUY over price of Y, then what we can say is this, that you don't need to substitute at all because your equi-marginal principle is met, which means for a given level of income, you must be maximizing total utility, right? Now, but what if now price of X goes down to PX dash? With this ratio, MUX over price of X dash will now be different than MUY over price of Y. So what will happen is that now that X goes down, previously the price of X was PX, now it's PX dash. When the denominator becomes smaller, this whole left hand side will become greater than the right hand side. So MUX over price of X dash will become greater than MUY over price of Y. Does that make sense, guys? Why? Because now the price of X is going down. Our response will now be not the same anymore, because what? We want to buy more of X because marginal utility per dollar spent for good X is more. So I will buy more of X and I will buy less of Y. But when I buy more of X and less of Y, my MU of X starts to fall because of the law of diminishing marginal utility, and MU of Y will start to rise because of the same reason, and that would mean this left hand side will start to fall and the right hand start to rise as I keep on buying more of X and less of Y. So this substitution should continue or keep on continuing till my MUX over price of X dash, which is the new price, should equal to MUY over price of Y. So when the price were, let me go back to it, when the price were equal, we did not need to substitute. But when the price went down, we have started to buy more of that good, and that basically resulted in us to buy more of X and less of Y. So what I'm saying here in summary is this, that when the price goes down, the marginal utility per dollar spent goes up and you buy more of that good, and that explains why our demand curve is downward sloping. So look at this, guys. When the price was px, I was buying, for example, Q1 of x. But when the price goes down to px dash, I'm buying more because the marginal utility per dollar spent is going up. So I'm buying more of this good. And when I join these 2 points together, I get myself what we call an individual consumer's demand curve, which says this price goes down, quantity demanded goes up because of the marginal utility per dollar spent going up. So that's the first thing we need to know, is how do we derive an individual consumer demand from demand curve. And the answer is this: then when the price goes down, according to the Marginal Principle, we buy more of that good, and therefore marginal utility per dollar spent basically is going up, and that results in the quantity for that good to be bought to go up. But what about the other good Y? What is happening in good Y? And the answer is, for the good Y, we will see a shift of the demand curve backward, because good Y is a substitute to good X, right? So good Y is a substitute to good X, and for good Y we'll say this, that since the price is going down for the substitute, the demand for Y should fall. Hence, for good X, there is what we call a price factor working in place. When the price goes down, the quantity demand goes up. For the good Y, however, there's a non-price factor happening, where we are basically going to buy less of the good because the good is becoming relatively expensive than the substitute, which is good X. The last concept we want to talk about when it comes to the utility theory is what we call the paradox of value. Paradox of value simply means that there is what we call a contradiction of value when it comes to different goods out there. For example, there is a paradox in water versus diamonds. If you look at water is very, very important for our survival. We say it's a necessity, which is important for our survival. So it's something which, if you don't have, you are willing to pay much more for that good, because it's extremely important for us. But when you look at diamonds, they are not so important for our survival. They are not that important. And the reason why they're not that important for our survival is because if I don't have a diamond, I can still live my life, right? But if you look at right now, the price of, for example, price of diamonds, let's call it PT, the price of diamonds very, very high. But when you look at the price of water, is very, very low. So one would argue this, that why is it that a good that is so important for our survival, like water, is so low in price, while diamond, which is so untrivial, unimportant for our survival or for our lives, is so expensive. And the reason is simply because of the demand and supply that goes into these goods. Look at diamond, for example. Right now, the reason why diamonds are very, very expensive is that they are very rare. And the fact that they're rare, the supply is limited. And that in turn results in basically for us to consume less of it. And because of this, if I could sort of look at my marginal utility for diamond, right? So this is the quantity versus marginal utility. If I look at the marginal utility for diamonds, I will find out that the marginal utility for diamond is downward sloping, of course, but right now I am somewhere here, where I am probably consuming very, very less of this sort of diamond, because I do not have much of diamonds available. So being at point A means marginal utility is much, much higher. Why? Because the quantity is lower. On the other hand, if you look at water right now, the consumption of water for us is basically very high. So if I sort of somehow draw this diagram, use the same diagram, I am probably here when it comes to water. So let me call this mu of T and let me call this mu of W. Because I'm consuming a lot of water, my marginal utility of water is right now less than marginal utility of diamond. And the reason is simply because the quantity that I'm consuming for water is much higher than the quantity that I'm consuming for diamonds. If, for example, a technology comes and suddenly diamonds do not remain rare and they become sort of ample in supply, then one would argue this, that probably diamonds will move from point A to somewhere here, and the mu will fall because people will now be able to buy a lot of them. So it's all about relative scarcity. It's all about basically marginal utility that decides the price of a good. So when it comes to the paradox of value, why is some good probably more expensive than the other? Well, the answer is simple, that probably we are consuming very little of it, and because we're consuming very little of it, the marginal utility is very high, and the marginal utility is simply the price we pay for the good. So price is equal to the marginal utility, which explains what we call the relative prices of goods, and therefore explains the paradox of value.